Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from Group 2, Decision Making Theory International class with the team members Reza, Novita, Sari, Andika Ade Setiawan, and Atika, Putri, Dianty. Today we will give presentation about Markov analysis. Markov analysis is a technique that deals with the probabilities of future occurrences by analyzing presently known probabilities. It has numerous applications in business. Markov analysis makes the assumption that the system starts in an initial state or condition. The probabilities of changing from one state to another are called a matrix of transition probabilities. Solving Markov problems requires basic matrix manipulation. States and state probabilities. States are used to identify all possible conditions of a process or system. It is possible to identify specific states for many processes or systems. In Markov analysis, we assume that the states are both collectively exhaustive or mutually exclusive. After the states have been identified, the next step is to determine the probability that the system is in this state. Matrix of transition probabilities. The matrix of transition probabilities allows us to get from a current state to a future state. Let Pij conditional probability of being in state J in the future given the current state of I. For example, P12 is the probability of being in state 2 in the future given the event was in state 1 in the period before. Let P the matrix of transition probabilities. The matrix is like the one that show up on the screen. Individual Pij values are determined empirically. The probabilities in each row will sum to 1.
Predicting future market shares. One of the purposes of Markov analysis is to predict the future, given the factor of state probabilities and the matrix of transitional probabilities. It is now very difficult to determine the state probabilities at a future date. This type of analysis allows the computations of the probability that a person will be at one of the grocery stores in the future. Since this probability is equal to market share, it is possible to determine the future market shares of the grocery stores. When the current period is 0, the state probabilities for the next period 1 are determined as follows, as you can see on the screen. For any period n, we can compute the state probabilities for period n plus 1. So then we can get the computations for the next period market shares that are 0.41, 0.31, and 0.28 from the equations. Meanwhile, for Markov analysis of machine operations, the owner of Tolsky Works has recorded the operations of his mailing machine for several years. Over the past 2 years, 80% of the time, the mailing machine functioned correctly for the current month if it had functioned correctly during the preceding month. 90% of the machine time remained incorrectly adjusted if it had been incorrectly adjusted in the preceding month. And 10% of the time the machine operated correctly in a given month when it had been operating incorrectly the previous month. For the Tolsky Works, we can get the matrix of transition probabilities for this machine, that is 0.8, 0.1 for the first row, 0.2, 0.9 for the second row. P1, P11 equals to 0.8 means that the probability that the machine will be correctly functioning this month given it was correctly functioned in the last month. Meanwhile, for the P12 equals to 0.2, probability that the machines will not be correctly functioning for this month given it was correctly functioning last month. For P21 equals to 0.1, probability that the machines will be correctly functioning this month given it was not correctly functioning last month. Meanwhile, for P22 equals to 0.9, probability that the machines will not be correctly functioning this month given it was not correctly functioning last month. So in order to answer the question, what is the probability that the machine will be functioning correctly 1 and 2 months from now? is 0.8 and 0.2.
Continue to my presentations with me, Andika Ade Setiawan. What is the probability that the machines will be functioning correctly 1 and 2 months from now? Look the calculations. P with 2 equal with P1 P, then substitute the number 0.8 and 0.2 multiple with 0.8, 0.2, 0.1, 0.9. Then the result is 0.8, 0.8 plus 0.2, 0.1 and 0.8, 0.2 plus 0.2, 0.9, and the result is 0.966 and 0.3 and 4. State probabilities for the machines example for 15 periods. As you can see in table of 15.1 period 1 until 15 state 1 and state 2. You can see the data. How about the period on the egg period when state 1 and there's the number, and state 2 the number 2 also. Now talking about the equilibrium conditions. First, it is always true that P next period equal with P this period multiple P, or P n plus 1 equal with P and P. At equilibriums, P n plus 1 equal with P multiple n. So at equilibrium, P n plus 1 equal with P and P equal with Pn. Or the simple formula, P equal with P multiple P. Equilibrium conditions for toxic machines. P equal with P multiple P. P1, P2 equal with P1, P2 multiple with 0.8, 0.1, 0.2, 0.9. Using matrix multiplications, there are the result. P1 and P2 equal with P1 multiple with 0.8 plus P2 0.1 and P1 0.2 plus P2 0.9. The first and second terms of the left side, P1 and P2 are equal to the first terms on the right side. P1 equal with 0.8 P1 plus 0.1 P2. P2 equal with 0.2 P1 plus 0.9 P2. The state probability sum to 1. Then all equal with 1, right? Well, for the toxic machines, then we can get the result, the last formula P1 plus P2 equal with 1. Take an example. We arbitrarily decide to solve the following two equations. P2 equal with 2.2 P1 plus 0.9 P2. Meanwhile, the formulation is P1 plus P2 equal with 1. Through rearrangements and substitution, we get this one, and until the result is 0.99666 and 7. So that's all our presentations. Next to my partner. Thank you.
That's all our presentation. Thank you for your attention.